For confounding compounding. Lessons from one field can often teach us something important about unrelated fields. Take the billion-year history of ice ages, and what they teach us about growing your money. Our scientific knowledge of Earth is younger than you might think. Understanding how the world works often involves drilling deep below its surface, something we haven't been able to do until fairly recently. Isaac Newton calculated the movement of the stars hundreds of years before we understood some of the basics of our planet. It was not until the 19th century that scientists agreed that Earth had, on multiple occasions, been covered in ice. Superscript 1. There was too much evidence to argue otherwise. All over the world sat fingerprints of a previously frozen world, huge boulders strewn in random locations, rock beds scraped down to thin layers. Evidence became clear that there had not been one ice age, but 5 distinct ones we could measure. The amount of energy needed to freeze the planet, melt it anew, and freeze it over yet again is staggering. What on earth, literally, could be causing these cycles? It must be the most powerful force on our planet. And it was. Just not in the way anyone expected. There were plenty of theories about why ice ages occurred. To account for their enormous geological influence, the theories were equally grand. The uplifting of mountain ranges, it was thought, may have shifted the Earth's winds enough to alter the climate. Others favored the idea that ice was the natural state, interrupted by massive volcanic eruptions that warmed us up. But none of these theories could account for the cycle of ice ages. The growth of mountain ranges or some massive volcano may explain one ice age. It could not explain the cyclical repetition of 5. In the early 1900s, a Serbian scientist named Milutin Milankovic studied the Earth's position relative to other planets and came up with the theory of ice ages that we now know is accurate. The gravitational pull of the Sun and Moon gently affect the Earth's motion and tilt toward the Sun. During parts of this cycle, which can last tens of thousands of years, each of the Earth's hemispheres gets a little more, or a little less, solar radiation than they're used to. And that is where the fun begins. Milankovic's theory initially assumed that a tilt of the Earth's hemispheres caused ravenous winters cold enough to turn the planet into ice. But a Russian meteorologist named Vladimir Koppen dug deeper into Milankovic's work and discovered a fascinating nuance. Moderately cool summers, not cold winters, were the icy culprit. It begins when a summer never gets warm enough to melt the previous winter's snow. The leftover ice base makes it easier for snow to accumulate the following winter, which increases the odds of snow sticking around in the following summer, which attracts even more accumulation the following winter. Perpetual snow reflects more of the sun's rays, which exacerbates cooling, which brings more snowfall, and on and on. Within a few hundred years, a seasonal snowpack grows into a continental ice sheet. And you're off to the races. The same thing happens in reverse. An orbital tilt letting more sunlight in melts more of the winter snowpack, which reflects less light the following years, which increases temperatures, which prevents more snow the next year, and so on. That's the cycle. The amazing thing here is how big something can grow from a relatively small change in conditions. You start with a thin layer of snow left over from a cool summer that no one would think anything of, and then, in a geological blink of an eye, the entire Earth is covered in miles-thick ice. As glaciologist Gwen Schultz put it, it is not necessarily the amount of snow that causes ice sheets, but the fact that snow, however little, lasts. The big takeaway from ice ages is that you don't need tremendous force to create tremendous results. If something compounds, if a little growth serves as the fuel for future growth, a small starting base can lead to results so extraordinary they seem To defy logic. It can be so logic-defying that you underestimate what's possible, where growth comes from, and what it can lead to. And so it is with money. More than 2,000 books are dedicated to how Warren Buffett built his fortune. Many of them are wonderful. But few pay enough attention to the simplest fact: Buffett's fortune isn't due to just being a good investor, but being a good investor since he was literally a child. As I write this, Warren Buffett's net worth is $84.5 billion. Of that, $84.20 billion was accumulated after his 50th birthday. $81.5 billion came after he qualified for Social Security, in his mid-60s. Warren Buffett is a phenomenal investor. But you miss a key point if you attach all of his success to investing acumen. The real key to his success is that he's been a phenomenal investor for 3/4 of a century. Had he started investing in his 30s and retired in his 60s, few people would have ever heard of him. Consider a little thought experiment. Buffett began serious investing when he was 10 years old. By the time he was 30, he had a net worth of $1 million, or $9.3 million adjusted for inflation superscript 1. What if he was a more normal person, spending his teens and 20s exploring the world and finding his passion, and by age 30 his net worth was, say, $25,000? And let's say he still went on to earn the extraordinary annual investment returns he's been able to generate, 22% annually, but quit investing and retired at age 60 to play golf and spend time with his grandkids. What would a rough estimate of his net worth be today? Not $84.5 billion. $11.9 million. 99.9% less than his actual net worth. Effectively, all of Warren Buffett's financial success can be tied to the financial base he built in his pubescent years and the longevity he maintained in his geriatric years. His skill is investing, but his secret is time. That's how compounding works. Think of this another way. Buffett is the richest investor of all time. But he's not actually the greatest, at least not when measured by average annual returns. Jim Simons, head of the hedge fund Renaissance Technologies, has compounded money at 66% annually since 1988. No one comes close to this record. As we just saw, Buffett has compounded at roughly 22% annually, a third as much. Simon's net worth, as I write, is $21 billion. He is, and I know how ridiculous this sounds given the numbers we're dealing with, 75% less rich than Buffett. Why the difference, if Simons is such a better investor? Because Simons did not find his investment stride until he was 50 years old. He's had less than half as many years to compound as Buffett. If James Simons had earned his 66% annual returns for the 70-year span Buffett has built his wealth, he would be worth, please hold your breath, 63 quintillion, 900 quadrillion, 781 trillion, 780 billion, 748,160,000 These are ridiculous, impractical numbers. The point is that what seem like small changes in growth assumptions can lead to ridiculous, impractical numbers. And so when we are studying why something got to become as powerful as it has, why an ice age formed, or why Warren Buffett is so rich, we often overlook the key drivers of success. I have heard many people say the first time they saw a compound interest table or one of those stories about how much more you'd have for retirement if you began saving in your 20s versus your 30s changed their life. But it probably didn't. What it likely did was surprise them, because the results intuitively didn't seem right. Linear thinking is so much more intuitive than exponential thinking. If I ask you to calculate 8 plus 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 8 in your head, you can do it in a few seconds, it's 72. If I ask you to calculate 8 times 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 8, your head will explode, it's 134,217,728. IBM made a 3.5 megabyte hard drive in the 1950s. By the 1960s things were moving into a few dozen megabytes. By the 1970s, IBM's Winchester drive held 70 megabytes. Then drives got exponentially smaller in size with more storage. A typical PC in the early 1990s held 200-500 megabytes. And then, wham! Things exploded. 1999 Apple's iMac comes with a 6 GB hard drive. 2003 120 gigs on the Power Mac. 2006 250 gigs on the new iMac. 2011 first 4 TB hard drive. 2017 60 TB hard drives. 2019 100 TB hard drives. Put that all together, from 1950 to 1990 we gained 296 megabytes. From 1990 through today we gained 100 million megabytes. If you were a technology optimist in the 1950s you may have predicted that practical storage would become 1,000 times larger. Maybe 10,000 times larger, if you were swinging for the fences. Few would have said 30 million times larger within my lifetime. But that's what happened. The counterintuitive nature of compounding leads even the smartest of us to overlook its power. In 2004 Bill Gates criticized the new Gmail, wondering why anyone would need a gigabyte of storage. Author Stephen Levy wrote, despite his currency with cutting-edge technologies, his mentality was anchored in the old paradigm of storage being a commodity that must be conserved. You never get accustomed to how quickly things can grow. The danger here is that when compounding isn't intuitive we often ignore its potential and focus on solving problems through other means. Not because we're overthinking, but because we rarely stop to consider compounding potential. None of the 2,000 books picking apart Buffett's success are titled "This guy has been investing consistently for 3/4 of a century." But we know that's the key to the majority of his success. It's just hard to wrap your head around that math because it's not intuitive. There are books on economic cycles, trading strategies, and sector bets. But the most powerful and important book should be called Shut Up and Wait. It's just one page with a long-term chart of economic growth. The practical takeaway is that the counterintuitiveness of compounding may be responsible for the majority of disappointing trades, bad strategies, and successful investing attempts. You can't blame people for devoting all their effort in what they learn and what they do to trying to earn the highest investment returns. It intuitively seems like the best way to get rich. But good investing isn't necessarily about earning the highest returns. Because the highest returns tend to be one-off hits that can't be repeated. It's about earning pretty good returns that you can stick with and which can be repeated for the longest period of time. That's when compounding runs wild. The opposite of this, earning huge returns that can't be held onto, leads to some tragic stories. We'll need the next chapter to tell them.